The second video deals with calculations using x, y, and r and working on the Cartesian plane. In each case here, we are not allowed to use our calculator, but we are asked to work out the values of certain trig expressions. Okay, so in the first example, again, this is revision from grade 10, we are told that our angle theta passes through the point -3 and 4. -3 and 4, so we're talking about an ordered pair that would look like that. In other words, the angle we're dealing with is in the second quadrant. My x value is going to be -3. My y value is going to be 4. My theta, the angle I'm talking about, goes from 0 degrees over here round to that point over there. Now, in order to work out any trig ratios, we just need to know our x value, our y value, and our r value. And once you have x and y, you can always work out your r value using the theorem of Pythagoras. In other words, r squared is equal to x squared plus y squared. When you do your substitution, -3 squared plus 4 squared, you're going to get 25, and your r value is 5. Please remember, r is always positive. So these questions boil down to doing a diagram to check what quadrant you're in, working out, in this case, r using Pythagoras, and then finally we are going to do a substitution. And in this case, we were asked to work out the value of sine theta plus cos theta. Sine is my y value over my r value. Cos is my x value over my r value, and I have 4 over 5 minus 3 over 5. My answer just becomes 1 over 5. No calculators necessary. We're not asked in this example to calculate the size of angle theta. In the second example, I haven't given you an ordered pair. I've told you the value of sine theta. Okay, so if sine theta is equal to -5 over 13, notice your sine value is y over r. R can never be negative, so that minus sign must belong to your y value. Sine is negative in 2 quadrants, there and there. This tan theta greater than 0 looks like extra information, but it's actually making the sum easier, because instead of having to do the sum twice, I can say, well, where is tan positive? Tan is positive in that quadrant and that quadrant over there. So the only quadrant that satisfies both conditions at the same time is going to be the third quadrant like that. And so when I allocate my x, my y, and my r value in this particular case, this is the angle theta that I'm talking about. My y value is -5. My r value is 13. And the thing that I have to calculate is my x value. All right, so y is equal to -5. R is equal to 13, and again we go back to using our theorem of Pythagoras. R squared is equal to x squared plus y squared, and in this case we're calculating the size of x. So r squared minus y squared is equal to x squared. 13 squared minus, now please note, it's -5 in a bracket squared is my x squared value. Remember, you have to do powers before you do subtraction. So this becomes -5 squared is plus 25. 169 minus positive 25 is your x squared. My x squared value is 144. You might have been able to go directly to that if you remember your Pythagorean triple. Now, when you are taking the square root of both sides of an equation, the standard procedure is it's plus or minus the square root. I didn't have to do it in the first example over here because I know that my r value is always positive. Here, however, put in the plus minus. When you're working out either your x or your y value, put in that plus minus and then you make a decision as to which one you are going to pick. And in this case, because my angle finishes up in the third quadrant, I can see that my x value is going to be negative. Now we're asked to do the substitution, so we are going to go back here and say, well, sine squared theta plus cos squared theta. My sine value is minus 5 over 13. My cos value is minus 12 over 13. And in both cases, we are squaring those ratios. This becomes 25 over 169 plus 144 over 169, which gives us an answer of 1. This question might look slightly different, but in fact it's a very similar principle. We're told that cos of 20 degrees equals p, and you're asked to work out the value of tan of 20 in terms of p. Again, no calculators allowed. We're not actually just going to push the buttons. So here, same process. 20 degrees, I know, is going to land up in the first quadrant over here. Okay, it's between 0 and 90 degrees. What am I given here in this particular sum? Well, if cos of 20 is equal to p, it's p over 1. Cos is x over r. My x value, I'll draw in my right angle triangle, my x value is going to equal p, my r value is going to equal 1. And so using Pythagoras, I need now to find my y value. So y squared is just going to be equal to r squared minus x squared. 1 squared minus p squared, and when I take my square root, again, when you're working out x or y, you are going to go plus or minus the square root. Please notice you cannot say the square root of 1 and the square root of p squared. Okay, you have to leave it as the square root of 1 minus p squared, and clearly in this particular case our diagram is in the first quadrant, so our y value is going to be positive. Okay, y is positive the square root of 1 minus p squared. What was I asked to work out? The value of tan of 20, and we know that tan is our y value over our x value. As easy as that. Now, in this example over here, I've given you an angle in the third quadrant. Okay, 200 degrees. We're going to draw an angle over here. This would be 200 degrees. Okay, if I give you tan is equal to t, it's t over 1. I'm actually saying to you that your y value is equal to t, your x value is equal to 1. But now you need to think here. You're on the negative side of the x-axis. X can't be 1. So what am I going to do here? Well, clearly must look like that. My minus divided by the minus gave me my plus. So my y value is actually going to be negative t, and my x value is going to be negative 1. When I work out my r squared is going to be my minus t squared plus my minus 1 squared, which is just going to be t squared plus 1. When I work out r, it is the positive square root of t squared plus 1. And I asked you now for the value of sine 200. And so sine of 200 degrees is just equal to my y value, which is minus t, over my x value. My r value, I beg your pardon, I'm looking for sine. My r value, which is the square root of t squared plus 1. Right, if you turn to classroom mathematics, there are a couple of examples of the similar type for you to practice.